Hello and welcome to the Week 8 Extra Exercises walkthrough video. This week we're tackling a few topics including timers, working with files and also working with the serial port. You'll also see in the video that I'm going to go a little bit further with the serial port exercise using the actual Arduino emulator for, in this case it was a pump, but it's very similar to the robot assignment that's also being used. So that's going to be quite useful as you work on that. So yeah, enjoy the rest of the video.
So we'll start at the start. The first activity is on periodic processing. So for periodic processing, we are using timers basically. So periodic processing runs segments of codes at regular intervals that we can set. This is really handy in the real world because there's a lot of particularly sensor-based applications where you might want to take a reading, say every 30 minutes, you might want to update the weather or something like that. So the benefit of timers is that they wait more efficiently than things like the pause function or like writing a loop that just busy waits. So computationally speaking, timers are an efficient way to write code. They basically don't take up very many computational resources while they're waiting to execute their next run. So yeah, that's the big benefit of using these guys. So for this task, we're going to create and start a timer that runs this callback function here every 0.2 seconds for 100 iterations. So this callback function, it generates a random number and adds it to an array called y. Then it plots y against sort of the number of data points so far. And then it updates that every time the function's called using draw now. So the main thing we have to do is actually create the timer. So I'm going to jump into MATLAB. I'll clear all the stuff I had from before. And we're going to start creating this timer. So we'll start off by naming it. So we're going to create a function called timer demo. And within this function, we'll have our timer callback function. So I'm just going to bring this one back up and we'll actually copy that out. So we're going to make this a sub function. So y n plus 1 equals randi 20. And then we're going to plot from 1 to the length of y, so basically from 1 to the number of data points so far. And then we're going to do a blue line with a star marker. And we'll do the draw now so that it updates every time this function is called. So some things we need to do now, well, we need to end both functions. That's a good place to start. We're going to need to create an array y that we can keep storing this data in. So I'll create that out here so that it continues to be updated. And then we're going to need to create our timer. So I'm just going to call it capital T. And let's have a look at the requirements. So the first requirement we were given is that we want to execute this function. So timer function for this one will be at timer callback. So the function that will run will be this callback here. We've also been told that we want this to happen every 0.2 seconds. So we set period to 0.2, which is in seconds as units. We've also been told that we want 100 iterations. So we set tasks to execute to 100. If you don't specify a number of tasks to execute, the default is that it's an infinite, so it'll run forever. And the last one we need to worry about is something called execution mode. And I've actually brought up some info on the web to explain this one a little bit further. So there's 4 execution modes available with timers. There's single shot, fixed ray, fixed delay, and fixed spacing. So single shot is it runs once and that's it. Period doesn't matter, doesn't really get used. So that's not particularly handy. That's, yeah, a little bit useless really. Fixed delay, fixed rate, and fixed spacing all use period, but the point at which that wait period starts is different. So let's have a look at the execution. So this little dash line here is our time. So when the timer starts, and let me just grab a little spotlight. So when the timer starts, we have some delay, then the timer will execute, then it's added to the queue. So there's some lag with anything else that might be in the queue, and then the timer function runs. In fixed spacing mode, the period starts after timer function finishes. So if we had our function here, it would run through this entire function and then the next period would start after this function ends. So then it kind of waits for that 0.2 seconds, it calls it again, there'll be some queue delay, and then the timer function will run again and the process repeats. In fixed delay mode, the timer executes, it's added to the queue. As soon as the timer function starts to run, that's when the 0.2 second wait period would begin, assuming we're using 0.2 seconds. So that's when the next wait period begins. So in other words, if we had our function here and we use that mode, as soon as it entered this function, it would get added to the queue again to be run again. The last option is fixed rate. So that one, as soon as the timer executes, the period starts. So it gets added to the queue and then it waits however long, adds it to the queue again, even if the last run hasn't finished. So if you've got quite long periods, then sort of fixed rate or fixed delay might be appropriate because there shouldn't be too much of a build-up in the queue. So for example, if you're waiting every half hour to take a new temperature reading, then that's probably fine. You'll get quite consistent readings every 30 minutes and there's not much of a risk of the queue getting too big. If you have a shorter period, it's probably better to use this fixed spacing because it waits for the entire function to finish before it queues up the next one. What that means is that you don't have any risk of overlap. You're not going to have the function getting called sort of 10 times before the first one's finished running or anything crazy like that. So you'll have much more predictable delay when you've got kind of a small period. That's going to be a lot more predictable. So long story short, for this example, I'm going to use fixed spacing. So I'm going to bring that one up and I'm going to type in fixed spacing and I'm going to get rid of my spotlight at this point. Close that off. And then the last thing we need to do is actually start that timer with the start command. So I'll open this up so we can see the full product. And if I hit run, away it goes. So it's generating a bunch of random numbers as high as 20. And once it gets to 100, which is still a little way away yet, it'll end up stopping. So I'll let that run. And almost there, and that's it. So that's using a timer. So there was a bit of a reflection question there about how this would be useful for temperature monitoring. Pretty much you could read from something like a serial device, so you could have an Arduino or something like that set up with a temperature sensor, and you could queue it up to read every 30 minutes, for example. Say you just need to get a weather update every 30 minutes. So that could be a real world application, along with pretty much any other sensor data. So that's how it can be used for real applications. Next up, we're going to look at writing to a file. So we're going to create a function called generate sample data. And within this function, we want to create and open a file called sample-data.txt, and we're going to want to write to that. So we're going to write a for loop that iterates 100 times, writing a random number between 1 to 20 on a new line with each iteration using this fprintf statement. And then we're going to close the file. If we've done all that correctly, when we run it, we should see a text file with the name sample data being created in our directory that our function is saved in and populated with 100 random numbers. So currently there's nothing here called sample data, so it doesn't exist yet. So that's going to be created by this process. So I'll create a new one. It asks us to call the function generate sample data, I think. Yep. So function generate sample data. I might minimize this a little bit so that we can see the instructions. Next up, we're going to create and open a file called sample-data.txt. So give it a name and open it up. So use fopen. Give it the name that you want the file to be called. And then you set whether you want it to be read, write, or append. As a little bit of a refresher, I did bring up this table before. So these are the different modes for reading and writing in MATLAB. R is opening a file for reading. W opens or creates a new file for writing. And if it already exists, it basically discards all the contents and starts from nothing. A opens or creates a new file for writing. If there is data existing, it'll append to the end of the file. The rest of them are kind of read and write. The, I guess, benefit of that is that you don't have to like open it for reading, then close it, then open it for writing. However, the disadvantage is it becomes a lot easier to make a mistake and write instead of read or something like that. So I prefer RW and A because it separates the functionality. It means that you can't sort of screw up your own files. So that's pretty handy. So I'm going to use just W, long story short, which will discard any contents if there was an existing file. So W, and then we're going to go for I equals 1 to 100. Yep. And we're going to get a random number using this fprintf statement that I've provided. So fprintf, file ID. Here I've called it my file, but up here I called it file ID. So basically it's just whatever you call that file. Random number equals %d, so that's our placeholder for the random number. And I'm also going to make a note of what iteration that happened at. And then I'm going to go randi20 and which is the iteration. So we're storing the random number at this placeholder and the iteration number at this placeholder. End that off. And then the last step is to close the file. And that is super important as a step because if you don't close your files, it can cause two problems. The first one is that you can't open it somewhere else. So you wouldn't be able to open it in Notepad or Microsoft Word or whatever because MATLAB is keeping it open and it's kind of claiming ownership of that. So nothing else will be able to open it until you've closed it. The second one is just memory. Computers have limited memory. So if you have lots and lots of stuff open, particularly if it's quite large files, then eventually your computer is going to start to slow down for one, and then secondly, it'll crash. So closing files when you're done with them is really important. So now if I give this a run and save that file, nothing particularly exciting is going to look like it's happened, but if we go into our directory, we can see that this sample data.txt is being created. Open that up. And you'll see that you have 100 lots of random numbers. So mission accomplished. So in exercise 3, we're then going to do the opposite and we're going to plot the data. So we're going to use that same file that we just created and we're going to read from it and plot the data. Basically the same sort of plot as we had here. So we're going to do it with a delay each time. So I'm going to do it two ways. I'm firstly going to do it just using a while loop, which has like the busy waiting going on. And then I'm also going to show you how you can do it with a timer. Yeah, so let's get into it, I guess. So first up, we're going to create a function called plot sample data. So function plot sample data. Might minimize this again so we can go through this step by step. Next thing is to open. So I'll call it file ID. Open sample data.txt. This time we want reading privileges, so R. Then we're going to write code to read through the entire file, saving all random numbers in a Y array and corresponding iteration numbers in an X array. So we can create our empty arrays for X and Y firstly. And then we can create a while loop. So I'm just going to say while true. So we're going to pretend like we don't know how long this file is. So while true, we're going to get the next line using fget L, that's an L, not a 1. I've seen that mistake made before, so be careful of that one, of file ID. So that'll get the next line of file ID and then the next line and the next line and the next line. What happens when it reaches the end? Well, we need to check for that. So we can check something called isChar, actually, next line. So that's sort of short for if it's a character. So basically this is saying if the next line is not made of characters, then what we'll do is we'll break out of this loop. So the reason that that works is because once you get to the end of the file, it won't read any characters because there won't be anything to read. So this will return false. So sorry, this will return true. So if it's not characters, then it'll return true and it'll break out. Otherwise, if it is actually real code, then we want to read from it. So we can do that using scanf. So scanf is kind of the opposite to fprintf. So you give it the thing you want to scan, so the text you want to scan, and you give it the format it's in. So we can actually take this format from before, because we know that that's the format, and paste it in. So that's going to return two values, one for random number and one for iteration. So then what we can do is we can update x, add a new value to x, and that'll be the second item of values because the y values are here and the x values are here. So that's the second value. Same thing with y, except value is 1. I'll add some semicolons to suppress all this too. I've just realized I didn't add them in a few places. And then we can do the plotting, X, Y, and I'll make the line the same as it was for exercise 1. Draw that now. I'm just going to do a busy wait for this, so pause 0.2, and that off. Open that up so you can see the overall product. And then that should be everything. Oh, actually, hang on. Got the most important part, closing the file. So when I run that now, away it goes. And that'll happen for 100 loops because we've got 100 points in that sample data file. So very shortly it will end. Almost there. And there it is. Cool. So that's our while loop wait. So that's doing like a busy wait every time. The more efficient way is to replace this while loop with a timer. So what we can do is actually we can pretty much use our timer from before. So let's take this guy over here. And what we'll do is we will convert this while loop into a function called timer callback. And all of that. So a couple more modifications to make. Firstly, for tasks to execute, we would want to get rid of that one because we don't actually know, theoretically, we wouldn't know how long this file is. So we're going to get rid of that and let it default to infinite. And then we're going to say, like, if the character, if the next line doesn't contain characters, we'll actually stop the timer and we'll delete the timer. And at that point, we'll also close the file. So we bring that one up into here. So then we need to end that overall function. But you can see there's not a lot of differences in the code. Oh, we can also get rid of this pause because we don't want that pause there anymore. So there's not a lot of differences. Pretty much we've just modified that while loop into a function and we've changed this sort of end condition a little bit. And that's pretty much it. You also want to make sure you don't leave any F closes down here because it'll actually read that before it finishes running the timer. So let's run this. And away it goes. So again, that should run all the way to 100 and hopefully it will end properly without any grumpy red text. So let's see how it goes. And there we have it. Okay, so it didn't like that I deleted the timer. That's okay. So you can just get rid of that line and just stop it instead. Cool. So that is using a timer for that. You could, yeah, play around with that some more to get it working how you would want it to for your assignment, but that's sort of two alternatives for that. Obviously, it's a fair bit more complex when you're reading from multiple files and all that sort of stuff, so that's sort of a lot of work for you to do. Next up in our exercises, we're going to move on to having a look at serial. Hi all, probably a bit of a weird jump in the video. I'm recording this about a year later because the serial port content has changed in MATLAB slightly. So I'm just re-recording this sort of second half for exercise 4 and 5 so that it's actually up to date for 2022. So the only two exercises that focused on serial for this extra exercises video were 4 and 5, and they're both quite short ones. So let's dive straight into it. Exercise 4 just asks us to list the 4 steps for serial input and output in MATLAB and asks if all of these steps are essential. So I'll start up an annotation. So there's 4 steps. The first step is it's kind of 2 steps in one. It's create a serial object and connect to the device. It kind of sounds like 2 steps, but with MATLAB's new way of doing serial ports, you actually only have to write 1 line of code that does both of these things. There's a single function that handles both of those, and we'll look at that in exercise 5. All right, so step 2 is then to configure the connection. So if you need to change any of the characteristics of the connection, you would do that now. Then step 3 is to read or write data. So you would either gather data from the Arduino like you will be doing for your pump assignment, or if you need to write data back to the Arduino or other serial device, then you can do that too. In this subject, you're just going to need to read. And then the last step, very important step, is to disconnect from the device. And the reason that's important is because once the serial port is open, it can't be used elsewhere until it's closed again. So the new way of doing serial ports is a little bit less clunky for this, so you shouldn't run into too many problems, but that's where you do your like clear serial port. So it'll be something like clear SP, assuming your serial port was called SP. And if you forget to do that, you can just use clear all and it'll clear everything that's open, including the serial port. Cool, so that's exercise 4. The last question asks to write down the line of code that will connect to a device on serial port COM1 with a baud rate of 9,600. So I might actually bring up MATLAB for this. Let's stop annotating. Let's bring up MATLAB because I was playing around with it. Oh, let's actually clear that annotation. I was playing around with this earlier. So I'll just clear everything, CRC. So the command for opening up a serial port would be, let's just say SP equals serial port. The question asked COM1 with a baud rate of 9,600. I don't actually have any devices connected to COM1, so it gives us this error. But if we wanted to connect to the actual Arduino that I've got plugged in on my computer, then we could use the, I think it's called list, serial port list, to see what serial ports I've got connected. I've only got one device connected, so it's coming up with one COM port. Pretty safe bet that that COM port is for this Arduino. So what I could do is connect to that instead, and we can see what a successful connection looks like. A successful connection will show us sort of those key characteristics of our serial port object. So these are some of the things that you can change in that step 2 if you need to. Cool. So let's have a look at how we could actually read from this thing now. So we can use the command read line and pass it the serial port object. And you can see there that it's reading line after line. So you can kind of imagine how this links to your assignment, because in your assignment, you're going to need to continuously read lines of data from this device. So that's for the moderate and advanced levels at least. So that would be how you would do it. You'd have some sort of timer ideally, or some sort of loop that can go through and continuously gather data and update the plots accordingly. So that's it for the updated add-on in 2022. I'll wrap this up here and stitch together these 2 videos. Hopefully they don't look too clunky. Thanks for watching.